Hello and welcome to my science tutorials. In today's video, we are going to be talking about how to differentiate rational functions. Before we begin, if you are new to my science tutorial, make sure you subscribe to our channel so that you will be updated when we upload new videos on this channel. So let's go ahead. So assuming we have a function, let me use a blue color. Assuming we have a function of the form y is equal to x on x minus 2 then x minus 3. So this is our function and we have to what? Find the y, the x, or we have to differentiate this function. How do we go around differentiating such a function? Now if you look at this function very well, we can see that these two functions are dividing each other. So normally the idea of using what the quotient rule would come to mind, but this is wrong, because this is wrong in the sense that these are not just what two functions dividing each other, but then at the denominator we have what? A product of what? Two functions. Okay, so this is what? In a rational form. Okay, so we cannot use the quotient rule to differentiate this function. So if we definitely want to differentiate this function, we need to what? Convert it into what? Partial fraction. Okay, so once we are able to convert partial fraction, all right, so let's have a look at how we go around to differentiate this function using this as an example. So with this, let's just for now ignore the y over here. So to convert this rational function into partial fraction, we equate this to what? A certain equation. That is, we say what? X on what? X minus 2 then x minus 3 should be equivalent to, let's say, a variable a on what? X minus 2 then plus another variable b on what? X minus 3. So this is the process of what? Converting a rational function into what? A partial fraction. So from here we can see that the LCM for both sides is the product of these two functions at the bottom over here. So we have the LCM as what? X minus 2 then x minus 3. So this will go here 1 multiplied by x will still give us x is equal to x minus 2 will go here. Okay, we'll cancel this, leaving what? X minus 3. So we have the a multiplying by what? X minus 3, then plus this will come here, will cancel each other, leaving this. So this will come and multiply the b. So we have b multiplied by what? X minus 2. Alright, so from here we need to find the values of what? A and b, so that we can solve the we can get the partial fraction. Alright, so let's say let x be equal to what? Positive 3. Now when x is 3, we can see that 3 minus 3 over here will give us 0. So we have eliminated a, but then 3 minus 2 will give us 1. So we still have b, so we can find x. X is equal to this. If x is equal to 3, then this means here will become what? 3 is equal to a into bracket 3 minus 3 then plus b into bracket 3 minus 2. So from here we have what? 3 is equal to 3 minus 3 is 0, so 0 multiplied by a is still 0, plus this is 3 minus 2, which is 1, so 1 multiplied by b is still b. So it therefore means our b is equal to what? 3. Now again, let's say let x be equal to what? If x is equal to what? Positive 2, we can see that here can also be what? Dealt with. So if that is the case, it means the x over here, we are still using this function to find both. So it means that x over here is now what? 2 is equal to a into bracket 2 minus 3 then plus b into bracket what? 2 minus 2. So we have 2 is equal to what? 2 minus 3 is negative 1 multiplied by a, so we get negative a then plus what? 0b. This is still 0. So it means our a is equal to what? Negative 2. So it means at the long run, converting the rational function into a partial fraction, we have what? X over what? X minus 2 x minus 3 is equal to what? The a is negative 2, so we have negative 2 on what? X minus 2 plus b is what? 3 on what? X minus 3. All right, so now that we have the function in a what, in a partial fraction form, we can now go ahead and differentiate what we have over here, okay, so that we get what, our final answer as the differentiation of this function, since both of them are equal. All right, so let's go ahead and differentiate that function. So it means our y is now equal to what, negative 2 on what, x minus 2 plus what, 3 on what, x minus 3. So we are now going to what, differentiate this function. Okay, so if we differentiate that function, we get dy dx to be equal to what, d dx, that is, we are differentiating the function negative 2 on what, x minus 2, then plus 3 on what, x minus 3. All right, so our dy dx becomes the differentiation. It means we have to differentiate each of these functions individually, since they are what, two functions what being brought together by what, the summation sign or the plus sign. So it means we will have to differentiate the first function, that is what, negative 2 on what, x minus what, 2, then plus this as 1 plus d dx of what, the differentiation of what, 3 over what, x minus 3. All right, so our dy dx is equal to, from here we can bring the negative 2 we have over here is a constant, or we can rewrite everything over here as what, let me have this. So all that we have over here can be rewritten as what, negative 2 then x minus 2 raised to the power negative 1. So we bring this to the top, so it becomes x minus 2 raised to the power negative 1. Then we do that for this side as well. So we have d dx into bracket 3 here, x minus 3 raised to the power negative 1. Then we bring this out, we close the bracket. Now our dy dx is now equal to, now the 2 over here is a constant, so when we are differentiating a function, we can bring the constant outside and then we differentiate just what we have over here. So we bring the negative 2 out, then we differentiate what we have over here, just x minus 2 raised to the power negative 1. Then we do the same thing over here, we have 3 outside, d dx of just what is inside over here, that is x minus 3 or raised to the power negative 1. All right, so dy dx is now equal to what, now we still have this negative 2 over here, that is over there. Now this function over here, just the x minus 2 raised to the power negative 1, looks like a certain function. Now in our previous tutorial we talked about what, how to differentiate, okay, how to differentiate a function using what, the chain rule. And this function looks like a function that needs us to use what, the chain rule. By the chain rule, it means we need to differentiate the entire function over here as 1, and then we differentiate what is in the bracket differently and we multiply all of them. Okay, that is how the chain rule works. So it means, first of all, if we are going to differentiate this, let me use another color to show that, let me use green. So we use the negative 1 to multiply the entire function over here, so it becomes what, negative 1 multiplied by what, x minus 2. Okay, then we now differentiate the function that is just in the bracket. So if we differentiate x minus 2, we get what, just 1, because if we differentiate x is 1, so that is what, 1, and we differentiate 2 is 0, so it's still 1 over here. Then plus this 3 is here, we have the 3. Then the same thing applies to this one, we need to use what, the chain rule to differentiate this. So we need to differentiate this as a whole, and then we differentiate what is just in the bracket. So we use the negative 1 to multiply everything over here, so it becomes negative 1 multiplied by what, x minus 3. Oh sorry, if we differentiate this, we subtract 1 from the power, so here becomes minus 2. So the same thing over here, minus 2. Then we differentiate just what is in the bracket. So if we differentiate x minus 3, we get just what, 1. So it's still over here. So it means our dy dx is equal to what, negative 2 multiplied by what, negative 1 will give us what, positive 2 into bracket x minus 2 all raised to the power negative squared, and still multiplied by 1 is still positive 2. Then plus we have positive 3 multiplied by negative 1, that will give us what, negative 3 multiplied by positive 1 is still negative 3. So we have negative 3, then x minus 3 raised to the power what negative 2. So from here our dy dx is equal to what, 2 on what, x minus 2 all squared, then minus 3 over what, x minus 3 squared. That is, I'm bringing this, okay, this under this because of the negative 2 over here. I'm also bringing this under this because of the negative 2 over here, and that is how come we have this as our answer. So in the long run, our dy dx, if we are to differentiate that partial fraction that we derived from solving the rational function, our final answer is going to be what, positive 2 on what, x minus 2 squared minus 3 on what, x minus 3 squared as our final answer. Alright, so now that we've dealt with the first example, let's look at other examples so that we can appreciate what we are doing. So let me use black for this example. So we are to differentiate the function y is equal to what, 2x on the function 2x minus 1, then what, x minus 3. Alright, so first of all we need to what, convert this function into what, into a partial fraction so that we can be able to what, solve it easily. So in that case, this is equivalent to, let's say, a function a over what, 2x minus 1, then plus b on what, x minus 3. So from here we say what, the LCM is what, the product of these two functions, so 2x minus 1, then x minus 3. So it means this will go here, 1 multiplied by this is now 2x is equal to, this goes here, cancels this, leaving this, so we have a multiplied by what, x minus 3, then plus b, this will go here, will cancel this, leaving this, so this now comes and multiply the b, so we have 2x minus 1 over here. Alright, so from here what we need to do is just to what, look through the equation and see if there is a way we can what, simplify this equation and get the value of what, a and b. Now if we look at this, we can see that if we let x be what, positive 3, we can get rid of a and then we can find b easily. Okay, so from this equation, let me put a dot over here. Let's say what, let what, x be what, positive 3. Now when x is 3, we have this becomes 2 into brackets 3 is equal to a into brackets 3 minus 3, then plus b into brackets 2 multiplied by what, 3 minus 1. Okay, so we get 6 is equal to, this is now nil, becomes 0. Then we have, this is what, 2 multiplied by 3 is 6, minus 1 is 5, so we have what, 5b. So from here we can make just what, b the substitute by dividing both sides by what, 5. So it means our b is equal to what, 6 on 5. Alright, so now that we have b, let's see whether we can find the value of a. Now if we look at what we have over here, there's no way we can get b from here easily. Okay, so it's either we see we expand this whole equation so that we'll be able to what, solve it like a simultaneous equation and get the value of what, a. So doing that, let's expand this entire function that we have over here. So let me use another color for that. Let me use deep blue over here. So we have the 2x from here is equal to, we multiply through, we get ax minus what, 3a, then plus we do this, we get 2bx minus what, b. Alright, so it means we have 2x is equal to, we have x over here, so we group them. Okay, so we have what, if we have this, then plus 2bx, then minus 3a minus b. So it means 2x is equal to, if we factor out the x, we have x a plus what, 2b, then minus 3a minus b. So from here, if we compare coefficients, okay, we can see that here has what, an x multiplying it, here also has an x, so it means we can equate the two of them. So we can say what, a plus what, 2b, sorry, this is 2b is equal to what, 2 over here. But we know that b is what, 6 on 5, so we can do the substitution and get the value of a. So it means our a is now equal to 2 minus what, 2 into bracket, the b is 6 on 5, 6 on 5. So if we punch everything here into the calculator, we are going to get negative 2 on 5. So it means if we convert this rational function into a partial fraction, this is what we are going to get. We are going to get this 2x on what, 2x minus 1, x minus 3, to be equivalent to the function our a is now negative 2 on 5, so we have negative 2 on 5 multiplied by what, 2x minus 1, then plus the b is what, 6 on 5 multiplied by what, 3 minus, x minus 3. Alright, so it means in the long run our y is equal to this function over here. So we have negative 2 on what, 5 multiplied by 2x minus 1, then plus 6 on what, 5x minus 3. So from here we can now differentiate this function and get what, our final answer. Alright, so if we are to differentiate the function, that is this function over here, this is what we get. So we have our dy dx now being equal to d dx of the function negative 2 on what, 5, that is 2x minus 1, plus 6 on what, 5x minus 3. Okay, so let's quickly solve this. So our dy dx is now equal to what, d dx of the function negative 2 on 5, 2x minus 1, okay, then plus d dx of the function 6 on 5 multiplied by what, x minus 3. Okay, so our dy dx is now equal to, we can rewrite this entire function as what, d dx of what, negative 2 on 5 multiplied by what, 2x minus 1. That is, this is a fraction and we are bringing this to the top, so raise the power negative 1. Okay, so we close the bracket. Then the same thing applies to the second one. We have d dx. Now this is what, 6 on 5, so we have 6 on 5 multiplied by what we have over here coming at the top becomes what, x minus 3, raised to the power negative 1. This is 3. Alright, so from here we know that these are just constants, so we can bring them outside and just differentiate what we have in the bracket. So we have dy dx is equal to what, negative 2 on 5 d dx of the function just 2x minus 1 inverse, plus 6 on 5, then d dx of the function x minus 3 inverse. Now, like I said earlier on when we were solving the first example, to differentiate a function that looks like this and has a power, we need to use what, the chain rule. And by using the chain rule, it means we differentiate this as a whole, then we differentiate what we have in the bracket as well. So it means our dy dx for this example is, we still have the constant negative 2 on 5. Let me use another color for the rest. So let me use deeper blue or violet. So if I am to differentiate this function, first of all I need to differentiate it as a whole. So it means the negative 1 will come and multiply the entire function, then we subtract minus 1 from here. So we have negative 1 multiplied by what, 2x minus 1. Then if we subtract minus 1 from this, we get what, negative 2. Then we now multiply by what, differentiation of what we have in the bracket over here. So if we differentiate 2x minus 1, we get what, just 2. Okay, then plus, we still have our constant 6 on 5. Then if we differentiate this, it goes the same way. So the negative 1 comes and multiply this. So we have negative 1 here multiplied by what, x minus 3 raised to the power negative squared. Then we differentiate what we have in the bracket, which is what, just 1, because if we differentiate just x we get 1, and this is a constant, so it becomes 0. So from here it means our dy dx is just what, the multiplication of everything that we have over here. So if we multiply 2 by 1, -1, we get what, -2. So -2 multiplied by 2 on 5, we get what, +4 on 5 multiplied by what, 2x minus 1 raised to the power -2. Then plus 1 multiplied by -1 is what, -1 multiplied by 6 on 5 is what, -6 on 5. So we have -6 on 5. Then x minus 3 raised to the power -². So finally our dy dx is now equal to what, 4 on 5 multiplied by what, if we change this, multiplied by what, 1 over what, 2x minus 1 all squared, then plus -6 on 5 multiplied by what, 1 over what, x minus 3 squared. So our dy dx, that is, we are rewriting this in a more suitable way, will become what, 4 on what, 5 into bracket 2x minus 1 all squared, then minus 6 on what, 5 x minus what, 3 squared, as our final answer for differentiating example number 2. Okay, so let's have a look at what, one final example, and then we end this beautiful tutorial. So the last example we want to look at for this tutorial is what, y is equal to what, 3x minus 1 on what, x plus 2, what, 2x minus 1. Now because I've gone through how to solve, how to convert this into what, a partial fraction twice, I believe you could do that. So I'm just going to write the result after what, converting this into a partial fraction, and I expect you to be able to what, do the conversion yourself, so that you can keep the tutorial as short as possible. So if you are able to what, convert this rational function into a partial fraction, this is what you get. You get 7 on 5 multiplied by what, x plus 2, then plus 1 on what, 5, 2x minus 1. This is the result that you get. So from here it means what, our y is now equal to this function we have over here, that is what, the function 7 on 5 x plus 2 plus what, 1 on what, 5, 2x minus 1. So if we are to differentiate this function, our dy dx now becomes what, d dx of this entire function, that is what, 7 on what, 5 this plus 1 on 5, 2x minus 1. Okay, so if we expand the bracket, our dy dx becomes what, d dx of the function 7 on 5 x plus 2, okay, then plus d dx of the function 1 on 5 2x minus 1, and that is that. Okay, so from here we can bring dy dx here, then we have what, we can break the fraction outside, that is what, 7 on 5, then d dx of just what is left at the bottom over here, so which becomes what, x plus 2 raised to the power -1, then plus 1 over 5 what, d dx of the function 2x minus 1 inverse. Okay, so from here dy dx becomes what, we still maintain this, we have 7 on 5, then we differentiate this. So as usual we use the chain rule, so we use the -1 to multiply this, so it becomes -1 multiplied by what, x plus 2, then we subtract -1 from here, so it becomes -2. Then we now differentiate what is in the bracket. So if we differentiate x plus 2, we get what, just 1, then plus 1 on 5, then we differentiate this to, it becomes -1 multiplied, so we have -1 multiplied by what, 2x minus 1, it now becomes power 2, If we differentiate 2x minus 1, we get what? 2. So it means our dy dx is now equal to what? If we use 1 to multiply negative 1, we get negative 1 multiplied by this, we get negative 7 on 5 into bracket x plus 2 negative what squared. Now plus, if we use 2 to multiply negative 1, we get negative 2 multiplied by this, we get what? Negative 2 on 5 multiplied by what? 2x minus 1 or to the power negative squared. Alright, so if we rewrite everything we have over here in a more suitable way, we get what? Our dy dx to be equal to what? Negative 7 on 5 into bracket x plus 2 squared, then plus negative 2 on 5 2x minus 1 all squared. So finally our dy dx for this example is what? Negative 7 on what? 5 x plus 2 squared, then minus 2 on what? 5 2x minus 1 all squared. So thank you so much for watching, and I will see you in the next video. Bye bye.